Welcome to this screencast series titled The 7 Basic Quality Tools. This is just an introduction to the rest of the videos. If you're new to the quality profession, or maybe you've been working in manufacturing or a service industry for some time and now you're moving into a more quality-oriented role, this set of screencasts will be an excellent introduction to some of the basic tools of the quality profession. Also, if you're studying for one of your certification exams through the ASQ or maybe SME or another organization, this will be a great teaching tool to introduce you to the topic of these basic quality tools. If you're studying for your certified quality technician, certified quality improvement associate, there's others like a quality engineer. This material will be on the test, and these screencasts will prepare you to understand that material. So let's take a quick look at each of the 7 quality tools, and the subsequent videos on each topic will give you a lot more detail. But the first is the flow chart. Probably the most commonly seen of the quality tools, and it's simply a graphical means of mapping out the process and to show the user the flow of people, the flow of information, the flow of raw material through the process. It's graphical in nature. It helps if you're leading a continuous improvement project. Maybe you're auditing a quality system. Maybe you're looking at a lean manufacturing improvement project. The flow chart is going to be a great place to start to understand what does the process look like. The second is the check sheet. Very simple tool, but effective. It's a template for organizing your data, collecting and organizing your data just quickly. It's a template. This one's set up for defect types, and it's designed to just put tick marks as you encounter maybe a particular defect. You put a tick mark there. This ends up being the raw material that feeds into other quality tools or other methods of analysis. Next is the histogram. Very powerful tool and is certainly the launching point for a lot of other statistics, things like capability analysis. Lots of statistics can go along with this. But in its core, a histogram is simply a graphical display of variable data where the data is grouped into what are called bins. And it's a bar chart, of course, where the length of the bar is proportionate to the frequency of occurrence of the samples within that bin or within that width along the horizontal axis. Watch the video. There's a ton of great information there. And again, it's a great launching point for analysis and statistical tools of all types. The next one looks like a bar chart as well. Looks like a histogram. It's a little different than that, though. It's a Pareto diagram. It's most commonly used to organize and prioritize attribute data. It can be used for variable data as well. But as Joseph Duran explained, it's a very effective tool for separating the significant few from the trivial many. So it's a great tool for organizing root causes to a defect, defect categories. It's a great tool for if you're trying to direct your budget, your workforce, or your priorities. This is a tool for helping you do that. Next is the run chart. Again, graphical in nature, definitely a launching point for a lot of other statistics, and it's simply a way of monitoring, of charting your process, some output in a linear fashion, usually along some time sequence. This could just be some numerical sequence, but generally it's time. But it's just a way of looking at your process, looking at the output of some process or some dimensional measurement across time. The very close relative to the run chart is the control chart, which is a run chart, but added to it are some statistics, specifically the upper and the lower control limit. And in the video on control charts, I explain how the upper and lower control limit represents where the process should be running, or it represents the variation caused naturally within the process. And if you find that your process is running outside of the control limits, it indicates there's a special cause and there's a need to investigate why that is out of control. Next is the scatter plot, also a launch point for a lot of other statistical tools such as correlation or linear regression or others. But what we're doing here is displaying graphically the relationship between two variables. In this case, we're comparing a new home selling price to that same home's square footage, where each dot represents a home with a particular selling price and with a particular square footage. When you plot many of those homes onto a scatter plot, you can start determining whether or not a relationship exists between the two variables. And if there is a relationship, you can begin to characterize it and describe it and quantify it. So that's a scatter plot, powerful tool in manufacturing. And the last of the 7 quality tools is called the cause and effect diagram. Sometimes it's called the Ishikawa diagram, named after its founder. The cause and effect diagram is a brainstorming tool used to organize the root causes, potential root causes of a defect into categories referred to as the 6 M's. The 6 M's: machine, method, man, Mother Nature, material, and the measurement system are the 6 M's, which generally are the categories into which potential root causes will fall. So that's an introduction, again, to the 7 basic quality tools. I hope you'll watch the video. I believe it will be a great preparation for one of your certification exams, or simply to brush up on your knowledge of the quality profession. And if you like what you see, please subscribe to the Manufacturing Academy, and we will put out more of these screencast style videos for training and education purposes.